You guys see my screen?
Not yet.
You guys don't see my screen. Oh, present. I started recording.
I just talked to Vishal. He's gonna call you.
Yeah, actually,
he called you today.
he called me, but I was on the phone with somebody else.
Okay, maybe he's gonna join next.
Yeah. Yeah, ask him to join, please. We can talk about the things.
Yeah, he won't be able to join today.
Oh, he won't be able to?
Not today. He's gonna call you. Okay.
Okay, cool.
Yeah, he can watch the recording.
Yeah, he can watch the recording. So,
Abdul, can I ask you before you starting, like in the records which we are watching every day, like your screen, since you are the recording and you are the sharing, on the right side it's like our names appears sometimes. Like, is there any way to you to pin the entire screen that we can see? Because what we are doing, like me myself, I am watching in the TV, so after me like making it bigger size, so it's like on the site these things is like really disturbing.
I saw that. I agree. It's not. It's distracting. So I tried to Google it, but everybody said you cannot minimize that. See, right now when I'm doing it, I see this panel on the right side.
No, actually, Abdul, there is an option. No, there is a. You can change the layout, and if you change the layout, there is a spotlight. You're gonna see spotlight, and then it's gonna be a full screen. You can change.
Let me look into
that. Three dots, more options on the right hand side.
3 dots.
Yeah, in the bottom, 3 dots. Yeah.
Oh, yeah. I see the change layout.
Spotlight.
Oh, sorry guys, I didn't know this.
Okay, that's fine. And also, I want to mention one thing, but the quality of the video was better on the Zoom meeting when compared. So this one is not it doesn't have a good quality. Just want to let you know.
Okay. See, I always use Zoom before, so I don't. Maybe when I have it full screen here, maybe the quality is better. Let's see what happens today.
Abdul, you want to try full screen because it is still not full screen. I mean,
no, it is full screen.
It is okay.
Yeah, it is full screen.
It is full screen.
Yes, it's full screen.
Okay. So, anyways, we'll get started. So, there was a problem with this assignment. I just, after the class ended, I went back and saw the assignment question, like, how did I just give a create table and simple insert statements, right? So then I looked at it, and there was more to the question. So did you guys do the rest of the assignment? Oh yeah, first of all, did you guys figure this out?
It was missing at the first time you sent the questions back.
Yeah, I resent the questions, but I also updated in the assignments tab. Okay, so did you guys figure this out?
I did.
Yes, I did too.
You did too? So
yes, I did.
So, yeah, that day I realized. So after I ended up, so you have to find out the distance between this one and this one, this E and this E. You have to find out the distance between the. So you have to calculate the position of this, and this minus this. You will tell starting from here, go all the way till there. You have to find out the position of this, this minus this. So it will give you, this is 4, this is 2, right? It will give you 3. 4 minus 2 will give you 2, and then we will add -1 to that. Okay. The distance between this E and this E. So it is 1, 2, 3, 4, 5, 6, 7. So 7 minus 4 will give you 3. So -1 means 2. So it will give you 2 characters. So you have to do one in string. So within a substring, you're doing in string minus another in string. This will give you the position of the second hyphen. This will give you the position of the first hyphen. Okay, and then you do -1, and then that's how you get it. I don't know if you guys took some time to look at this, but the rest of the, yeah, I realized later that it was not the complete question. So So find all characters before the first hyphen, find all characters before the second hyphen. If you guys did this was the most complicated. Find the length of all. Did you guys do all of these? I'll just paste the answers here. I don't want to go into too much.
I did.
So find all characters before the first hyphen. So all the characters before the first hyphen, 818, 1234, and 67890. Find all characters before the second hyphen. So this is what it is. This one I just showed. Find the length of all phone numbers. Find the length of all phone numbers. The length of this phone number is 12. The length of this phone number is 14, and this one is 13. Sort data. So order by length of phone number. So this will sort the data. Sorry. So it will give you the biggest phone number at the bottom and the smallest phone number at the bottom. Remove the leading one from phone numbers. So if there is a one at the, this is leading, this one is called leading, this is called as trailing. So remove the leading ones. So you will say L trim will remove the one at the left. Yeah, it's not deleting, it will just not display it because we're not writing an update statement. So it will get rid of the one at the start. Remove trailing one from the phone number. So I want to get rid of the trailing ones. Trailing means at the end. Remember those terms, leading and trailing. So this will get rid of the trailing characters. So these are all the answers. Actually, I don't think I can send all of it. Let me send the first three. Send the first three and then these are all the answers. Okay. How about the next question?
We did some of them.
No, I didn't say the next assignment. I said the next question. 6th one I already did. 8 and 9 I asked you to do it. So okay. So I guess I just have to quickly explain this. Let me open this. So this, what I'm going to show is very important. You have this in Java, PLSQL, SQL, in every programming language, Python, if then else. If value is this, do this, otherwise do this. Without this, you cannot learn any programming language. In Unix, in PLSQL, in SQL, in Java, in Python, you have this if then else. Okay, it's called case and underscore decode. Let's look at case and decode. Okay, so this is how case and decode works. Okay, so suppose you have a table empid name, and this is every time they ask this question, what is the difference between case and decode and which one is better? Okay, I'm sorry, not department ID. Let's take salary. Give me 1 second. Okay.
We do have screen, but maybe font size also needs to be increased.
Is this better?
Yeah, that's better.
So suppose I have an employee ID 1, name Abdul, salary 10,000, and then 2, Irfan, salary is, make it 10,500, salary is 5,000, salary is 5,500, 5,500, oh, sorry, I don't want to give that much salary, 5,500, and then I have salary as 4,800, and then I have 4,000, and then I have one last salary, so I have salary 6,000. Okay, my requirement here is this is how they'll say at work. If salary greater than, they'll give you this. This is called as a business requirement. They will give you a business requirement and say, if salary is greater than 10,000, I want you to display rich. Salary is between 5,000 and 10,000. Display salary and display the status. This would be a fourth column. Display status as rich, display status as middle class, and then this, if salary is less than 5,000, display status as poor. Okay, is this clear to everyone? So they will give you employee information, and they'll say find out, because they want to find out who is the rich, who is poor, and who is earning less. Okay, just change name. Okay, so how do you do this? So I am giving you multiple conditions. If salary is greater than 10,000, so if then else. Okay, I'm saying if this, then do this. If this, then do this. If this, then do this. Okay, so let me show you how to do that. Okay, so in SQL you have something called as case and decode. I never use decode. I always use case. I'll tell you the reason why. So let me create a table temp underscore sal and temp ID number, temp name varchar2. Who did this? Did anyone attempt this?
Yes, I did.
Okay, that's okay. I still want to cover this because this is important. So is the screen visible? The screen is clear, right? It's not too small, right?
It looks good to me.
Looks good.
Okay. So guys, this is important, not just for SQL. This is important for other programming languages. Okay, so okay, 10, 5, 5, 5. I'm going to place my cursor here and I'm going to execute this, or I can highlight all of this and execute this, either way. Okay, so data got inserted. Let me give you this. So please execute this. Okay, execute that, and let me get rid of all of this. I want to display a final column, which is called as status, and the business requirement is if salary greater than 10,000, display rich. If salary between 5,000 and 10,000, display middle class. And if salary less than 5,000, display poor. Okay, so select temp ID, temp underscore name, depth, salary from, first write down the simple columns you want. Invalid and salary. Okay, now I'm going to write a case statement. I always like to try it below. I always try to write my case in the next line. So I will say case, okay, and then I will type in when salary greater than 10,000, then which and salary between 5,000 and 10,000, and middle class when salary less than 5,000 and poor, and as status.
Abdul, you put 1,000 instead of 10,000.
Oh, that's why everybody is rich. Okay, you're right. Sorry. So 5,000. Okay. Now, then I'll just say at the bottom, I will just type in order by salary DSC. See, so is this clear? I'm calculating this for everybody in the company. If salary is greater than 10,000 rich, between 5,000 and 10,000, it's middle class. Less than 5,000, it's poor. This is clear to everyone.
Yes.
Okay.
Clear.
Now you can rewrite this. If I don't need to write this last when salary less than 5,000, right? Because I'm saying if salary is greater than 10,000 rich, between 5,000 and 10,000 middle class, else I can just say else. I can just comment this out. I can just say else poor. I don't need to write this last condition because so greater than 10,000, between 5,000 and 10,000, and everybody else would be less than 5,000 only, right? So I can just write it this way. I don't have to write the last condition. I can just write poor and it works the same way. Is this clear to everyone? Please execute this.
Computer programming that we use in Python or basics. No?
Yeah, this if then else is used in every single programming language: PL, SQL, Unix, Python, everything. Without if then else, you cannot have a programming language. So you have your PL SQL here. So, okay, this is, okay, we will cover this later, but I'll show you a sample PLSQL programming language, a block. So I'm saying declare a underscore integer. So I'm declaring an integer equals to 9. And then I'm writing this statement. If a is not equals to 10, this is an invalid input. So if this, then do this. Otherwise, do this. So I'm passing a value 9. I'm saying if the incoming value is not equals to 10, then this is an invalid input. Otherwise, it's a valid input. So you can just execute this. Oh, sorry. We will do this next week, okay? Do PLSQL next week. See, the invalid. If this is an invalid input, okay, because the incoming, the value I'm passing is 9. Okay. So if I if I pass 10 here, if I pass value 10, then it will say valid input. So if I execute this, see, valid input 10. So don't worry about this too much. I just want to say that every single programming language you have these if then else. Okay, very important. Give me 1 second. Okay, so let's get back. So this is how you write if then else in SQL. Okay, case when salary is greater than 10,000, then rich. Salary is between 5,000 and 10,000, poor. And then salary is less. You don't have to write. This is not necessary. You can just write. You don't have to write 3 conditions. You can just write else poor. Now, can someone tell me? Let me answer this question. So I wrote 3 conditions, right? This incoming condition, sorry, let me think of a scenario. Wait. Salary is greater than 10,000. So each salary can only satisfy one condition. You cannot have a salary satisfying 2 different conditions here. Here? Is that clear to everyone? For example, if I over here type salary greater than 5,000, or suppose if I type salary greater than 4,000, let's do that. If salary greater than 4,000, okay.
Excuse me, Abdul.
Yeah.
Yeah, actually, I don't know the PLSQL. So in this, we use when instead of if. When salary is greater than 4,000, then?
This is not PLSQL. This is SQL.
Okay. So, I mean, instead of if, we use when in this?
Yeah, this is the syntax for case. Yeah, if it is if then else, but it's called case, and you use when and then. When salary, yeah, it is called if then else in all programming languages. In SQL, you use
like
when
that
salary.
And then, okay,
That's
but you have to initialize with the case.
Yes.
And at the end of it's mandatory, you have to give the end as a status.
Correct.
So that the status is going to be the column then, right?
This is the alias we are giving. We can give it A, B, C, X, Y, Z, whatever you want. It's just an alias. So
okay, I got you.
You can give. Okay. In Unix, you start with IF and end with FI. I don't know if you guys know Unix shell scripting. You start if statement in Unix with IF and end with FI. So, anyways, so what is happening now? I said salary greater than 4,000. Everybody is rich. Salary between. So there are this one. Look at this. Look at this one. 4,800. It is satisfying 2 conditions, right? It is satisfying this condition and this condition, right? So you will not see 2 outputs. If a condition if an incoming value satisfies a condition, it will give this value and exit out. So a record will not go through this, this, and this. The moment it satisfies this condition, it will exit out. The next record will come in. Is this clear?
It means that the first one is going to be on our table, right?
Okay, so let me go back here. So I created a new condition, okay? I created a new condition saying if salary, sorry, I already wrote it down here. If salary is greater than 4,000, I want to display rich. Okay, this is my output. I'm saying status here, first record. It comes in, it satisfies this condition, right? It's greater than 4,000, right? So immediately it will say rich, and it will exit out.
Let's see.
this record will come in. It says it's greater than 4,000, right? So immediately it is satisfy this condition and it will exit out. This 4,800 comes in. First condition, it's satisfied, so it will say rich and exit out. Even though this one satisfies this one also, but it will not go through multiple conditions and then say which all of them which are true. Incoming record can only satisfy this condition or this condition or this condition. Even if it satisfies both conditions, it will exit out after it satisfies the first condition. If it this condition and this condition, so 4,800 means it is satisfying actually this condition and this condition, right? 4,800 is satisfying this condition and this condition, right? But it will not go to this one. The moment it satisfies this one, it will exit out and then the next record will come in. Now 4,000 will satisfy this one and this one. So it will just take this value and exit out. 6,000, it is satisfying this one and this one. Okay, not this one anymore. So it is satisfying this one and this one, right? 6,000 is greater than 4,000 and 6,000 is between 5,000 and 6,000. So you will not see rich and middle class like this. You will not see something like this. Okay, because even though it is satisfying two conditions, which condition did it satisfy first? It satisfied this condition, so it will exit out. Is that clear to everyone?
Yes.
Okay, what happens if I put this condition first? So you'll say, okay, Abdul, you just said it satisfies the first condition and then it will exit out, right? What happens if I put 5,000 first and then this one? Okay, let's see. See, now whatever condition is coming first, it is satisfying this one. See, previously we had all of this as this one, right? See, now what happened? I got the output like this because I switched this. I put this one first on top and this one below, right? If you guys are understanding. So I put in like this. But be very clear.
So Abdul, it's very important to do like 1, 2, 3 to know what to put first. You mean like this is very important?
Yes. Yes.
Because it's going to mess up the whole table.
Yeah, it is. It's not going to mess up your data. It's just that it's going to display different values. Now, because the incoming row is 10,500, it is not going here. It is not satisfying this condition, right? 10,500 is greater than this one, but it's going to satisfy this one. So immediately you'll see rich. Now look at
Well, Abdul, quick question. How often do you have data or that satisfies multiple conditions?
Every day.
Mm-hmm.
Every day. Okay. So so let's get back. Okay. So okay, I'll give you a practical example what I do at work. The next, look at this. I'm tagging Irfan as rich, but over here Irfan is middle class because previously Irfan was satisfying this condition because this was the first condition. Now Irfan is satisfying this condition first and this condition. Irfan is satisfying both of these conditions, but this time it's satisfying the middle class condition first. So guys, be very careful when you write your case statement. Okay. Okay. I work at a university. Okay. We have people who are both employees and student. We call them as student employees, right? We have some employees, we have some students, we have some people who are both employees and students. So this is how we get data. Okay, we have emp ID, name, sorry, we have emp ID, student ID, name, and salary, address, phone number, everything. So I am just an employee. So for me, data will look like this. Null's name is Abdul, and then salary is 1,000. Then I have somebody else who is, for example, Wuso. So he is an employee and a student. So that Wusel's student ID is 100, something like this. Okay. And then salary is 500. Then I have one person who is just a student. So I will take Irfan. Sorry, Irfan doesn't have an employee ID. Irfan has a student ID, which is 102, 101, and Irfan, and his salary is null, right? I have data like this. Actually, we have more. We have guest workers, we have contingent workers, we have a lot of, I'm going to keep it simple. My business requirement is if a person has an employee ID, that person is an employee. I shouldn't even look at this one. Is that clear to everyone? My requirement is if a person has an employee ID, don't even look at student ID. So employee ID gets the highest preference in the hierarchy, right? So I shouldn't type. So I cannot type if. Sorry, I cannot type in here. I cannot say case when student ID is not null. Is not null. Case when student. This is wrong. When student I do not want to display student. And when emp ID is not null, I don't want to display employee. And when student employee ID is not null, and then I don't want to say when emp ID is not null, when emp sorry, I can put it next time. When emp ID is not null, and when emp ID is not null and student ID is not null, then I don't want to say employee. This is incorrect. Can someone tell me why? Because employee should take preference over student, right? Employee should take preference over student. Because if I write these three conditions, this is wrong, because this is what I will display. This is what I will display. Over here, Abdul has a student ID null, so it will not, when student ID is not null. So I will not, my record will not satisfy this condition. Then it will go here. So it will display employee here, which is correct. Look at this one. Okay. So it will not satisfy this. So, okay. So Wusel will be displayed wrong because I said when student ID is not null. Okay. So Wusel has a student ID and it is not null. So immediately I will say student, but my original requirement was the moment person has a student employee ID, don't even look at student ID. So this is wrong because Wusel has an employee ID and I'm tagging this person as a student, which is incorrect, right? What is the correct way of writing this? This should be first. Okay. And then this one. Okay. I don't even have to write the second condition. This is it. So now I will take this and over here I have to write, and I don't even have to write. Yeah. This should be, I hope you guys are getting it. It's slightly complicated, but just remember that hierarchy is important. Okay. Now what will happen if I write conditions like this? Employee ID is not null. First record comes in. I will not even look at student ID. This condition gets satisfied. This is correct. This was correct in both scenarios. Second record comes in. It satisfies this condition, right? Immediately this will be employee. Third record comes in. Student employee ID is not null, but employee ID is null. It will skip this. Student ID is not null. Student ID is not null. It's very important to write case statement and decode with the right hierarchy, because sometimes your records could be tricky and could satisfy more than one condition. So always type the one on the top which has the highest hierarchy. Is this clear to everyone?
Yes, but in similar scenarios, we can combine two conditions, this and this.
What do you mean combine two conditions?
Like,
This is the right way of doing it.
mm,
How else did you want to write this?
well, if you say, I mean, right now you're using a case statement, but isn't there some other way that you can combine two conditions, like if this is equal to this and this is equal to this, then this.
Yeah, you can. In case, you can write 100 conditions, right? I'm writing over here. You can write as many conditions as you want. And salary between 5,000 and 10,000, and you can also say and name starts with A, then middle class. You can write as many conditions as you want. I'm going to keep it simple. I'm not going to keep it type complicated. Okay, you guys can try it out. Okay, right now I'm just trying to explain, if a record satisfies more than one condition, make sure that your case statement is written properly. Is this clear to everyone?
Yes.
Okay, let me move on. I took already too much time on this. Now, there is another way of doing it. You can write the same thing with decode. Okay, the problem with decode, I'll tell you what. There is a problem with decode. So let me rewrite this. Oh wait, what am I doing wrong? And salary greater than 10,000. So once again, if a record satisfies more than one condition, make sure your case has the right hierarchy in the when. Okay, let's do the same thing with decode. Select employee name salary. I don't even see for case, I remember the syntax. For decode, I probably don't even remember the syntax. So decode. 1 second. Does anyone remember decode? Okay, that's okay. I don't remember, so I don't have. I'm going to just look at the final answers.
Decode is, I think, actually with the procedural. Go with the procedural things.
So you can. This is how you write decode. Okay. Don't look at all of this. This is complicated. Okay. So decode. Don't look at this. Say salary. So decode, you cannot use the problem with decode. The problem with decode is you cannot use range. You cannot say greater than 10,000. You cannot say between 5,000 and 10,000. You cannot say less than 5,000. In decode, you can only say fixed values like 10,500. Oh, sorry, this would be wrong. Oh, 10,500 is rich. Or you have to say 6,000 is middle class. And you have to say 5,500 is middle class. 4,800 is poor. Okay, and then 4,000 is again poor. You guys understand what the problem is, right? You cannot in emp underscore name. Select employee name salary. What are the column names? Employee name salary. Oh, not from HR employees. See, I cannot use greater than 10,000 between. That doesn't work in decode. So there is a way to fix this. Okay, there is a way to fix this. That is the reason. So guys, don't just know how decode works, but never use it. I never use it in my life. I always use decode. Let me look at this. Okay. Look at this now. Okay. What am I going to do here? I cannot, case is straightforward. I can use greater than 10,000, between 5,000 and less than 5,000. I can simply give values. Decode, I cannot use ranges. If I have 1 million values, I have 10,000 employees. Will I write 10,000 different, covering all different scenarios? No, right? So there is a way around it. My requirement here is, what is my requirement? Okay, my requirement here is if salary is greater than 10,000, should be rich. Salary is between 5,000 and 10,000 is middle class, and salary less than 5,000 is poor. Unfortunately, I cannot use ranges, right? So I'm going to use something else. Okay, I'm going to full decode that I'm using ranges. So what am I going to do? I'm going to divide 10,000 with, I'm going to divide this salary by 10,000. Actually, wait. I'm going to divide salary by 5,000. I'm going to divide this salary by 5,000 for everybody. What will I get here? If I divide salary by 5,000, I will get 2 point something, right? Something. Over here, I will get 1 point something, right? Over here, I will get 0 0.9, 0 0.85 something. Then over here, I will get 1.25 something. Is that clear? Is this clear to everyone?
Yes.
Yes, it's clear.
Okay. Once I divide it by salary by 5,000, then I will say trunk of salary by 5,000. What does trunk do? Can someone tell me what does trunk do? I covered this.
It will remove decimals.
Very good. So it will remove decimals. So my output will be 2, 1, 0, 0, and then 1. Correct? Is that correct? Now,
Yes.
I will say if decode of trunk. So I will write here something like this. Over here, I will type in decode trunk salary divided by 5,000. This value is equal to 2. If this value is equals to 2, then this is going to be rich. This value is 1. Wait 1 second. Sorry. Do I use? Okay. So if it's 0, then I'm going to say poor. This will be poor. Why? Because their salaries are less than 5,000. This person and this person salary is middle class, right? Because they are between 5,000 and 10,000. So middle class. I'm going to do this. Okay. This is going to be middle class, right? Because their salaries are between 5,000 and 10,000. So how do we do this? Did you guys understand this first?
Yes.
Okay. So now, what am I going to do here? So get rid of all of this. I don't want to do all of this. First, I'm going to write my simple select statement. Okay. I have these values. I'm going to divide salary by 5,000. So I will get 2.1, 1.1, 0.96, 0.8, 1.2. Is that clear to everyone? Now,
Yes.
I will say trunk salary divided by 5,000. See what happens now. I'm going one step at a time. Guys, you will never be able to write this. Even I will never be able to write this decode trunk salary. If I show you this, you will not understand anything. So break it down. Break it down. First type in salary, then do salary by 5,000. This. Then do trunk of salary divided by 5,000. Keep building on top of salary. So if a person's salary is greater than 10,000, you will always have value 2, right? If a person's salary is between 5,000 and 10,000, you will have value 1. If a person's salary is less than 5,000, you'll have value 0. Now I will type in decode here. Decode, and I will type in trunk salary divided by 5,000. Sorry, let me just copy it from there. So I'll go to the next line, comma, and then I'll go to the next line. I will type in, if it's 0, then 4. If it's 1, then middle class. If it's 2, then I will say, which I don't have to write the last condition, but I'll still write it. Then I'll remove it at the end. Okay. And then I will say, I will close my bracket because I have one bracket here. This bracket is already closed. And then I will call this as, and I will call this as financial underscore status. I was hoping somebody would. Did somebody do this? I don't think anybody did this. Just call this as financial underscore status. Is this clear to everyone? Now you can get rid of this salary by 5,000, trunk of salary by 5,000. Is this clear to everyone? Yes or no?
Yes, it is.
Decode, you cannot use, sorry. Decode, you cannot use ranges. So are asking for only one operation in all one condition. I didn't understand that. Okay. So with decode, if they give you like three salaries, then it's easy. But if they give you millions of salaries, you cannot write between 10,000 and 15,000, between 5,000 and 10,000, less than 5,000. You cannot do that because ranges do not work in decode. Is this clear?
Abdul, it is clear, but I have one question. Like in that case, like what will the like perfect position to use this decode? Like, is it like really there is some place that it's
Very
100%
specific.
necessary? Yeah, necessary to use the decode.
They created decode first, and then they created case.
Oh, so it's improved after that. Okay,
Yes.
I got it.
Yeah. So that is an immediate interview question. Which one is better, decode or case? So you can type in decode versus case Oracle. This website is excellent. See, case function is much better option because case is more flexible. He didn't explain it clearly, but more flexible means you can use ranges. Is that clear?
Right. Perfect.
See, Oracle introduced case later on. or the case function can do everything decode does plus a lot of other things. Okay, read about it. But like the example I just said, see, decode performs an equality check, or you can only use equal symbol. Case is capable of other logical expressions such as less than, greater than, between. I mean, that's the main. See, before case, people would have to write something like this. You have to write a formula and all of that. They made life easier by creating a case. Clear? In the interview, they'll ask you, how do you write if then else in Oracle? You'll say case or decode. Then the immediate interview question, which one is better, case or decode? You say case is better because you can use ranges like greater than, between. In decode, you can only use equals to 0, equals to 1, equals to 2. Okay, I don't want to cover more than this. Is this clear?
Yes.
Okay. Hey guys, we are slowing down. Okay, yeah, go ahead.
So this a case and decode is only about the numbers, or?
No.
Because let's say if it's a case, and let's say if we don't have the number in the table, but I need like a if status. So how can I use the greater than, smaller than? I have to type like a decode, right?
You can still do it. You can still do it. For example,
let's say million people, and they are in the.
Yeah, I got it. I'll explain.
You understand what I mean?
So yeah, I got your question. So let me show you. I want to say if job ID is SH clerk, then I want to say rich. If job ID is AD assistant, then poor. If job ID is this one, AD press, or I can say all the job ID starting with S, they're rich, they're poor. All the job ID starting with A, they're rich. You can do that. So you can say select employee underscore ID. This is a varchar field, right? First underscore name, and then job underscore ID. Then I will type in decode, bracket open. I will say, sorry, decode. I will say job underscore ID, then comma, and then I'll go to the next line, and then say sh underscore clerk. I will call this person as poor. Let me take mk underscore rep, then something like this. Okay, and then I will say I'll close this bracket out as status. So let me execute this. See, if it doesn't satisfy a condition, then it will come as null. Okay. Now, how can I say all the ones starting with S or all the ones starting with A? All the ones starting with A. How can I say that? I cannot use
maybe A and
like. I cannot use
like.
Wait. I use something like this. A percentile. I don't know if I can use a percentile as.
How about with the trim, like left trim, right trim, and then put that statement there?
Yes, very good. Actually, that's the right way of doing it. Even I forgot about that. That is correct. Okay, let me try this. If not, then I'll just. No, this doesn't work. Okay, you're right. So, did you guys get what? Who said this? I forgot.
It's me, Cameron.
Oh, Cameron. Okay, yeah, you can say sub str. The sequence SQL statement which you guys hate, substring. So you can say job ID, and you can say, starting with A, right? You can say 1, 1, right? Yeah, this is how you can do it. Job ID 1, 1. So you get A, right? Now you can say decode. So I'll just copy this formula like I did in the previous, I calculated that. Job ID. So I will say substring. Will this work? I don't think this will work. No. Or can I say? No, not sure. I thought this was the right way. Decode job ID substring. No, not substring. Decode. I want to search for decode. See, you can only say equals to 10,000 equals to. No, it's always with numbers. 1. Supplier ID. ID is also a number. See, unfortunately, you cannot use decode for ranges of numbers. So you cannot use decode with numbers. Okay, let's see. The values, it is on data type of the first value number. If no, decode will no better. You guys want to try it out later? I don't know if can decode be used with varchar.
I will check myself later. That's fine. So we can discuss maybe next class if I'm not able to find it.
Okay, try it out. Okay, I have never used it because I always stick with case.
I'll try myself. Thank
Okay.
you very much. Next class I'll let you know if I can find it.
Okay, so let's look at the. Okay, who wants to do this assignment? Who wants to share screen? Someone wants to share screen. I'm going to stop presenting. Someone share screen and let's do the 6th assignment. Come on, someone, please. We only have less than 1 hour.
Whose turn today, guys? Come on.
There's no turn. Anybody can do it. Come on, guys, please.
Okay,
Don't make me pick someone. And why is it's always the same people sharing screen? I want somebody else.
That's what I was meaning. Like, there's so many people. Like, I shared, Ramo shared, Ali shared. So there's so many people there.
Okay, I don't want to discuss it. Somebody just share. Next class, I'll just pick somebody who doesn't share.
I can share the screen, but I already have it done. So
It's okay. Even if you're done, you can share. But next time you can share. Sonia. He's already sharing, so we can proceed.
Do you guys see my screen?
Yeah.
The Oracle, the SQL screen, right?
I can see SQL developer. Yeah.
Okay. If you want, then I'm gonna go one by one like that. Again, I'm gonna type, or it's ready because I did all of them myself.
No. Get rid of everything.
Get
rid of all the answers. No. If that's the case, I can just send the answers, right?
No. Here.
Yeah.
Okay. So here is gonna be defined the highest salary in each department in the HR.
No, I didn't see yours.
Excuse me.
Can everybody go on mute?
So everybody can see my screen now.
Yeah, I can see your screen. You can proceed.
Okay. Find the highest salary in each department.
Don't.
Okay.
First, query the table. Simply query the table.
Yes. I know that.
Don't start max and all those things. First, simply write which table you will want to query. Okay.
So here is the HR employees, and then I need to find the highest salary here, and each department, which means that it sounds that like there are many duplicate departments, and I'm gonna take it like a group by. I'm gonna do this one group by and find the max salary. So here, as I understand that, I'm gonna do a department and max salary. If you want, I can do one by one, or I can explain like that. So
no, you don't have to explain. I already explained. You can just
here, and then I go here, group by. So because of the duplicate department, I'm gonna take this one as a group by.
You're going to group all the department as 10 into 110, all the 20s into 120, all the 30s into 130. That's it. So, that's the answer.
Yeah.
So this is the highest. I actually did this. I remember I did this in the last class. So order by department _ ID or order by max salary, whatever you want. Okay.
Yes.
Okay. So, next question. Can you paste those answers, or at the end you can just send an email to everyone? Just send an email. Actually, can you paste it right now so people can execute it at the same time?
Of course. I'm gonna do with the question over here.
Okay.
Let's go to the second one. So find the lowest salary for each department. So what I'm gonna do, I'm gonna copy paste. So because it's the lowest one, so I'm gonna do this one min. It's gonna be same question because again the HR employees department. So the lowest salary, which means there's gonna be minimum salary.
Same thing.
With the
you
only
just
change the minimum.
Yeah.
Yes. Here.
This is a minimum salary in each department. Okay.
Yes. So
group by is complicated, guys. Okay. Can you change your view as well? Click on the 3 dots and click on that spotlight thing.
Okay.
On the bot, click on that and click on change layout and click on spotlight. Yeah, this would be better. Okay, share screen.
Sure.
Okay.
Yes, sir. Okay, now it's gonna be here. I will try to.
1 second. Do you guys know what is an index? Who knows what is an index?
I mean, I
don't think we talked about it.
No, we haven't talked about it. That's why I'm asking. Who knows what is an index?
I researched myself. I mean, I can explain, but if you want, you can go ahead.
No, let's go ahead. I'm going to explain after the.
It's to index the records and helpful for sorting.
Yes, so index will help you return the data faster. Okay, I'll give you a quick example. I always give this example. In a book, on the first page, you have an index, right? So if I want to go to chapter 1 is page 1 to 10, chapter 2 is page 11 to 20, chapter 3 is page 21 to 30, something like that. If I want to go to chapter 3, I don't have to turn each page one by one and go to chapter 3, right? Starting of chapter 3, I can just look at the index and immediately go to chapter 3, right? So anyways, I will cover that, but like you have, whenever you create a table, it gets logged into all tables. Whenever you create a column, it gets logged into all tab columns. Whenever you create a constraint, it gets logged into all underscore constraints. Similarly, when you create an index, Oracle database has a system table called all underscore indexes. It gets logged into all underscore indexes. Yeah, go ahead.
So here, a question, it says that each table and then the number of the indexes. So first of all, I'm gonna create the index, all indexes. Here is the all indexes, and later then I'm gonna find that how many index has each table. So here is a table name, which means that I'm gonna find like a group by the table name.
Very good.
Right?
Yes, because each table can have more than one index.
Yes, more than one index. So group by, it's going to be a table name, and the number of the indexes, I can do count of index.
You can just do count star also. You can just do count star also.
Okay. But count star is going to find the tables here, right? Not the indexes.
It's the same thing because you're going to do a group by table name. So it would try it out. Just say group by table underscore name and execute this. So it will tell you how many indexes each table has.
Okay.
So can you go to employees table?
Sure.
On the left side, double click on employees table.
Here.
HR.employees.
Here, right?
Yeah, double click on that. Go to the index tab. So you have 6 indexes here, right?
Yes, let's check here.
Yeah, please check. Let's see if your query is returning the right data.
Okay. So here, it's going to be, oh, I can find.
So just type in where. Very good. When you're using group by and you want to do where, you have to do before the group by. We covered this.
Yes. Employees. Yeah, 6.
So employees table has 6 indexes, and we just tested that, and it looks good. Okay, let's move on to the next one. Can you paste that?
Yes. Okay. I did myself like that, but I think it's the same thing.
Okay. Find the table which has the highest number of columns in the entire database. Each table has many columns, right?
So here it's based on the columns. So I try to find first of all of the columns.
First query which table? First, tell me which table to query.
Columns. All tab
columns.
Okay. Here is the columns, a column table. It's like all of the columns. And here the question is that highest number of columns for each table. It means that like do the group by of the table names here.
Yes.
Okay, and then find the how many number of the columns, and this one is the columns of the tables. So
count star.
Yes. So here I'm gonna do table name. Table. Sorry. Count. I will find how many of the column underscore name, because this is the the columns, right? Here I'm gonna do group by table name.
Yes. So this will tell you how many columns each table has.
Yes, and then we can do the order by, because highest, it says highest, so we can say order by. I will find here this. Okay. And which means that highest means I'm gonna do descending.
Very good. This is the answer.
Yeah, it's gonna be 179.
There is a table with 179 columns in it.
Yes, I did myself at home. I check it and I said that yes, there is 179 columns.
Okay.
So each database.
Excuse me.
So which database in that? So if he wants the database, what will you do?
Database owner.
So put owner in the select statement.
Yes, he can. We can do here owner.
You want to
And-
find out which schema it is in.
Yeah. Okay.
Yeah, whatever you have in your select has to be in your group by.
Yes, sir. Here.
So it is in which schema? Apex underscore 040000. You can query that table. Do select star on the table.
Okay. Any of them?
Yeah, the 179 one.
One second. No, okay.
Just do Control C and it will copy it. And then that dot the table name.
Here.
No, it's empty. You don't have anything in it. But it has 179 columns in it.
Yes.
Can you minimize that window which says Google meet.google.com is sharing?
This?
No, don't click on. Yeah, just hide it. Yeah. Is it clear? Let's move on. Let's not do this. Let me show you this one. Okay, let me explain. Go down. Skip this one. I'm going to show.
I think it's a 5 question here, and then join 2 tables.
Okay.
So it's the same question.
Thank you very much. I'm going to
My pleasure. My pleasure. I stopped sharing the screen.
Yes. Guys, this is how I want you to do assignments, okay? Once again, people who are sharing screen, they are learning much faster than you. Okay? People who are sharing screen, they are learning faster than you. Okay, can everybody go on mute? Okay, I forgot to cover this, the 9th question. I want to find out what is the Oracle database version. So you can query select star from $V version. It will tell you which version of Oracle database is. I have the 19C, which is the latest version. Okay, query, you can execute this in your SQL developer. It will tell you which version of Oracle database you're running. $V version.
What we are practicing right now, this is not PL, this is PL SQL.
I cannot hear you.
Hello?
Your voice is very low.
Can you hear me now?
Yeah.
Yeah, Abdul, I was asking that what we are practicing right now, this is PL SQL, right?
I'm not going to start PLSQL once we finish SQL.
Okay. Okay. So we will later talk about the difference as well, right?
Differences of what?
SQL and PL SQL?
Yes, let me cover SQL first and then I will go with PLSQL, okay?
Okay.
So looks like we will start PLSQL on Sunday. I was hoping to do it on Saturday, but it doesn't look like because you guys are slowing me down a little bit, okay? That's okay. One day is here and there is okay. We are still ahead of schedule, but I was hoping to do PLSQL starting Saturday. Looks like we will do it Sunday. It's no problem. Okay. Let me cover indexes. What is an index? What is an index? This is a very important interview question. You can ask Fahad, you can ask, I don't know, other people who are working. How many times they ask this in interview? Short interview question. Okay, short interview question. So what is an index? You have a table, employee ID, name, department ID, 1 up to 10, sorry, 1 up to 10, 5, also 50, 3, Ali, 30, something like this. Then I have 7, Sam 70, and then I have 4, Surab 40, something like this. Yeah, I have data like this.
Can you please zoom in to your the screen, because it's like really, yeah, perfect. Thank you.
Okay, so I have data like this. Okay, I want to find out employee ID 7. So I will type in select star from table where employee ID equals to 7. Oracle database will issue a query to the database. A pointer will be created. First, it will go and check this row. It will 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 check this row. It find out this one here. So it will first go and check every row in the database, in the table. Then it returns this. When a query you execute is checking the entire data in the table, it's called a full table scan. Called a full table scan. Okay, which is very bad. Right? Suppose you work for Apple. Apple has how many employees? 170,000, 180,000 employees. You want to find out employee ID 3. It will check all 180,000 rows and then display this. Right? It's doing a full table scan, which is a very bad design. Is that clear to everyone? Your query should never do a full table scan. Why is your table doing a full table? Why is your query doing a full table scan? So just like the example I was giving, suppose you have a book and you have chapter, then you have page number. Okay, chapter 1 starts at page number 1, chapter 2 starts at page number 17, chapter 3 starts at page number 36, chapter 4 starts at 55, chapter 5 starts at 67, something like this. Okay, and at the end of in your book, at the end of chapter 1, you have like a blue sticker which is coming out of the book, and then you have a green label. You guys have seen bookmarks, right? How the bookmarks look in a book, right? So then you have a yellow bookmark, and then you have a red bookmark, and then you have a orange bookmark, something like that. Somebody says go to chapter number 3. You see a yellow bookmark, you get hold of that bookmark and turn all the pages, all 36 pages before that, 35 pages before that, and you will go directly to yellow. What if you did not have this index? Index is the first thing in a book, right? Suppose you did not have this index and somebody is asking you to go to chapter number 3. You will start with the first page. You will turn 35 pages and say, okay, I am at chapter number 3. So which one is faster? With an index is faster, right? With an index and bookmark is faster, right? Otherwise, you're not turning every single page. You're not turning every single page in the book. You're directly getting hold of the yellow because it says chapter 3 and you just flip it. Is that clear to everyone?
Yes.
Okay. Same thing. Same thing. Okay. In a table, if you create an index on this column, data will, when you do select sort on the table, it will still look like this one. But internally, it will create memory pages. So records from 1 to 5 will be on records. So sorry, emp ID equals 1 to emp ID 1 to 5 will be on page 1. Okay. So employee ID 6 to 10 will be on page 2. Okay, employee ID 11 to 15 will be on page 3. Okay, let's just keep it like this. Suppose I want to go to employee ID 7 and you do not create an index, pointer will go here. It will check for the entire records in this column. But if you have indexes, internally it will have data sorted in ascending or descending order. You can tell if the index should be sorted in ascending or descending, but it will by default do it in ascending order. So internally this data will be sorted. Internally, you know how this data will be sorted? Internally this data will be sorted like this. When you do select star on the table, it will still look like this. But internally, this is how the data will be. 3, 4, 5. Internally, data will be sorted like this. These two records will be on. This record will be on page 1. This record will be on page 1. This record will be on page 1. This record will be on page 2. This record will be on page 2. Suppose if you have 11 Tom and this record will be on page 3. If you create an indexes, internally data will be sorted. If you create an index on this column, internally data will be sorted on this column and stored in memory pages. Suppose if I want to go to, suppose if I want employee ID 3, it will not do a full table scan. It will do a range scan from 1 to 5. It will only go to page 1. It will not even go to page 2 or page 3. It will immediately go here and do an index scan. Is that clear? Suppose you have a table with 1 million records and you're querying that table. Somebody else wants to query that table at the same time and there is no index on the table. You will lock that table for 5 minutes. Somebody else is trying to query that table. It will say, please wait, resource busy. Once you return data and your query completes executing, it will release the lock. When you do select star on the table, it will lock the table for that many seconds or milliseconds. Right now, the tables we have are very tiny. Suppose you have a table with 80 million records or 100 million records. Do select star on the table, it will lock that table for like 2-3 minutes. If somebody else, if there is like 10 people trying to query the same table and no index, it will be very frustrating. Is that clear? If a customer is trying to look up their invoices, okay, and there is one table with no indexes, you have an Amazon account, you're trying to see your invoice for the last, you have Bank of America, you want to see last month's invoice. So when you select from the drop down invoice and say May 2020, it will query the table and display the data in the form of a PDF. If there is no index on that invoice table, sometimes it will take longer, right? It will be moving around in circles because it is trying to query a table which is huge and somebody else has a lock on it. Is that clear?
Yes, so index is created to dismiss the slowdowns.
Index is
Right?
used to retrieve data faster. That is it.
Okay.
Index is a database object which is used to retrieve a data faster. Okay, just like I explained indexes in a book. Okay, let's move on. So we talked about it. Let's move on. So let me create a table. I think in my question fifth assignment, right? Sixth assignment. Sorry, this is Power Center. 6. Okay, so create a table. This is my question. Create a table. So I will write create table. Create table. I will create this table and then I will insert data. Okay, I created this table. I have data in it. Okay. Now, how do I know? So first of all, how do I know there is an index or no index on this table? So all you can do is go to this emp_1_20 and go to the index. Go to the index tab. You should know every single tab here. There is no index on this table. Now, when I do select star from this table where emp id equals 2, it will execute, right? Let me check the explain plan. So how do I know if it's doing a full table scan or not? So I will invalid create command. Oh, sorry, let me just come. Okay, this is, so let me copy this, open a brand new SQL worksheet. Execute the explain plan. Oh, sorry, execute. So when you, this is the explain plan. Do you see S9? Explain plan is F10. Do you see it's doing a full table scan here? Do you see this here? Full table scan. So this is a very bad design because I shouldn't be doing a full table scan here. Okay. So index, we have to create an index. Okay. So when do we create an index? This is important. Indexes are always created on a column which is used in where and join statements. Indexes are always created on the columns on which you're searching data for. You're always searching data for where on where statement, right? So always create an index on the column which is being used in the where statement. Now I have a table with 3 columns. User, the business user or end user, the customer can put this in the where statement, can put this in the where statement, can put this in the where statement. You cannot stop the user, right? You cannot tell the user use only employee ID in your where statement or use only name or use. Sometimes they want to see all employees in department ID 10 or they want to see all employees starting with name A. Okay, that doesn't mean you will create an index here, create an index here, create an index here. No, that is a very bad design. You will only create an index on the column which is mostly used in, which is most of the times used in the where statement. Usually you will filter out data with employee ID. So create an index only on this column. Now you guys can tell me, Abdul, if index is good, why don't we create an index on all? There is a table with 180 columns, right? We just saw that 179 columns. Why can't we just create an index on all 179 columns? No. If you create a table, if you create too many indexes on one table, it will slow you down. It will not make your query run faster. It will make your query run slower. Now, I'll tell you why. Suppose you created an index on this column. Internally, data is sorted in this format and saved. Suppose you create an index on name column also. You know what will happen? Internally, data will be sorted in. Internally, data will be sorted like this. A, B, N, R, S, T. Internally, data will be sorted on like this. And page 1 will have these 2 records. Page 2 will have something like this. Page 3 will have something like this. Because you're sorting the internally, 2 indexes will be. I mean, am I missing one more? Oh, wait. Why do I have? Oh, this is just an.
You're missing Tom.
No. Yeah. I just created this at the end. So Tom will go over here. So internally, this table will have 2 copies, one sorted on employee ID, one sorted on name. Suppose if you sort data, if you create an index on department ID also, now your internally you will have 3 copies of the same table. One on, because you created an index on this, and you create an index on this is how data will be stored, sorted on employee ID. If you create an index on name, data will be sorted on employee name and stored. If you create an index on department ID, data will be sorted on department ID. So you will have 3 copies of the same table. So you will have 10, then you will have 30, you will have 40, you will have 50, you will have 70. So internally data will be stored in this format. So page 1 will have these 2 records, example, page 2 will have these 2 records, page 3 will have these records. So the same data internally will have 3 memory, like 3 indexes, and data will be sorted in this format, and this format. So when you create too many indexes, your query will slow you down. It is better to have less indexes than more indexes. Your query will run faster with less indexes than with more indexes. Is that clear? Do not, if your table has 179 columns, don't create 179 indexes on 179 column. Internally, you will have 179 different versions, one sorted on employee ID, one sorted on name, one sorted on department ID. Is this clear to everyone?
Yes, usually which one is the most common one, Abdul?
Usually the one which users use in their where statement. Okay, if you look at,
Can you create a key column or something?
yeah, you will know, you will get a requirement, you will get the, from the business analyst, you'll get it. See, employees table has indexes created on, so if I go to the indexes tab, they have it on job ID, last name, first name, email, employee ID, manager ID, and department ID. So they don't have it on salary, they don't have it on, so they decided, okay, we are not going to create an index on commission percentage or salary or phone number, right? So they decided out of 11 columns, they only created indexes on 6 columns. Let's look at jobs table. Job table has how many columns? Has 4 columns, but they only created index on 1 column, job ID. Is that clear? So do not blindly create indexes. Read about it. There is a limitation on indexes. You can, technically, you can create on all 3 columns, but do not do that. It will slow you down rather than make it faster. Okay, so let me create an index. So how do you create an index? It's very simple. Before that, you should know what are the 2 types of indexes. There is B-tree index and there is bitmap index. What is an index? What are the different types of indexes? Every single interview. Without this question, they won't proceed. So what is a B-tree index? A B-tree index is created on a column with less duplicates. Created on a column with less duplicates, or created on a column with less duplicates, or also when a column has less duplicates, it's called as high cardinality. Same term. Less duplicates means high cardinality. Bitmap is created on a table which has more or high duplicates or less, or sorry, not less, low.
Less duplicates, low cardinality.
Yeah, less high duplicates and low cardinality.
Oh, high duplicates.
Yeah, high duplicates means, or sorry, more high duplicates. Or what's wrong with me? Why am I not able to tell? But if a column has very less duplicates, for example, employee ID will never have duplicates, right? So you should always create a B tree on this. What will you create on department ID? Or for example, you have another column called gender. Have MMMFF, something like this. what kind of index will you create here? You will always create bitmap because it has high number of duplicates. Is that clear to everyone? Is this clear to everyone?
So low cardinality is like when you don't have too many.
Low cardinality means high duplicates. For example,
Okay.
this column has too many duplicates. Employee ID has less duplicates, so that means it has high cardinality. So in this one, you will create a B tree. Is that clear to everyone?
Yes.
Another thing, if you create a primary key on a column, you create a primary key constraint. If you create a primary key constraint on a column, automatically a B tree index will be created. Remember that. If you create a primary key on this column, employee ID can be a primary key, right? Because no duplicates, no nulls. The moment you create a primary key on this column, it will automatically create a B tree index. Is that clear? Let me create an index on this column because it's doing a full table scan here. Do you see this word full table scan? So I will, this is how you create an index. Create index. Sorry, I forgot the, I always use the shortcut.
Index name.
Sorry, go ahead. Can you tell me?
Yes, index name on column.
So, yes. So this is how you should create index name. You can create ABC, XYZ, but always use IDX. That's a proper naming convention. Okay, you can say emp ID, IDX underscore emp ID on create index name on which column? On emp ID. Am I missing something? On
I think table name, right?
table name and then something like this.
Yes, I think.
Yeah. Create index emp ID on table and this column. So index is created on a column. So it says index created. Let me query this table before it was doing a, I'm sorry, before this thing was doing a full table scan. Now let's see if it's doing a full table scan. Right now it's not doing a full table scan. It's doing by index. Okay, it is not doing a full table scan. The other thing is, if you create this index, you cannot create this index on some other column. This index name is unique. For example, if I try to create an index on, for example, so emp underscore, I try to do this, it will say name is already being used. Name is already, so index is unique for each table. If you create an index in this schema, you cannot create that index again. Okay, you can create an index on some other, schema, the same index, but in this schema, you cannot reuse this index. Is that clear to everyone?
Yes, Abdul, it's clear. Can you run the first query without the condition? The table EMP120 index.
Run the query again.
No, with the analytic. So we wanna see the full. You see, the option is full here.
Yeah.
Even though we created the.
But we created index, but we are not using that in my wait statement, right? Now, so if I use name also, it will not work. Even if I use, so for example, if I say name equals, even this one will do a full, oh, sorry.
Yeah, this will be full.
It will still do a full table scan.
Yes, because we don't have an index on the column.
Yeah, it's still doing a, so that is the reason. Always create an index on the column on which you're doing a wait statement, on which you're searching data. Yeah.
Oh, okay, I understand. So on the where.
See, look at your cost to
Yeah,
run
that's
the
going to
query.
change. Yeah, cost will also change.
Your cost will be lower to run this query.
Before was 3.
Yeah. So what does
So,
cost mean?
Abdul, is it gonna show if you're gonna? I'm sorry about that. I think I missed that. Is it gonna show the index when you're gonna do the full table, like the select start full table without the where?
Yeah. So if I use name here, it will tell you it's doing a full table scan. I think I just showed, right? See.
No. I know, but like I had an issue that I gave the index to the one column, and then when I was doing select start from HR, blah blah blah, it showed me again the full without where. I didn't use the where.
Yeah. So yeah, once again, somebody just asked this question. So I created an index on this column, right? If I execute this, it will say you're not doing a full table scan. But if I get rid of this where statement, and if I just execute this one, this will again say full table scan. You have to use this index. You have to use this index to see, indexes are created at the column level. You cannot create an index at the table level. I don't know if that answers your question.
Yes, thank you. It was answered.
Okay. The other thing I wanted to show is look at your cardinality and your cost. Your cost will go down. It is one third the processing speed, and see the okay, ignore this cost. Look at the cost. Your cost is half now. Okay. Previously it was taking, sorry, it's not half, it's 2/3. Okay. Previously, if it was taking 3 seconds, now it will take, I'm just giving an example. Previously, if it was taking 3 seconds, now it's taking 2 seconds. Previously, if it was taking 3 minutes, now it's taking 2 minutes. So your cost to run this query on the Oracle server is 2/3. Is that clear? Is this clear to everyone?
Yes.
Okay. Now, so I said when do you create an index? Whenever you're using it in the where and the join. Okay, where we already understood, right? But now, why joins? Why do you create an index on this department ID and this department ID? Because you're joining on department ID and department ID, right? So the problem here is if you don't create an index on this one and this one, again, when you're joining these two tables, this 10 will go and check where all 10 is present. This 20 will go and check where all 20 is present. Do you guys remember joins, what I showed before?
Yeah.
Okay. So if I don't create an index in the where, I'll be using in the where, I'll be using on join. If I don't create an index on this one and this one, it will do a full table scan. So I'm doing it in equi-join. It will have to find a 10 here. So it will not, after it finds a 10, it will go on from top to bottom, and then it will return that. 20 will go from top to bottom and check. 30 will go from top to bottom and check. If you create a index, it knows not to do a full table scan. Is that clear? So the assignment question was create another table called department table. So I will create this table. Create this table. And in this one, I will insert some records into this table. Let me comment this out. I have some data in this table. And if I check the explain plan, it is saying full table scan, right? Just give me 1 second. Okay? Hello? Okay, so this is doing a full table scan, right? Now I want to join this table with this table. So how would I join this table? So my question is, join this table with this table and filter out some records. So how will I join this table? So I will say select star from this table, join B on A dot, I will join on department ID, right? I will join these two tables on department ID. A dot department ID equals B dot. This is how I join two tables. So this is how I join two tables, right? Now, because in employee table, I have employee ID, name, department ID. The other one has department ID and department name. If I want to see everything in one screen, I have to join these two tables. Now I will get the explain plan. When I do the explain plan, it is saying doing a full table scan because you need to create an index on the columns on which you're joining and on the where statement. So when I write this and I want to filter this data out, where A dot emp ID equals 1. I already created an index on emp ID, but I did not create an index on the columns on which I'm joining. Right? So it's still doing a full table scan wherever, see, wherever I'm using the where statement, it's down. Wherever I'm using the join, it's full. So the cost is too high. So how many indexes do I need in this query? I need 3 indexes, one on this, one on this, one on this. I already created one on this, right? So cancel this. So let me create index. So how will I create index? Create index. I cannot use this name, so I will say depth ID. So we'll say depth ID on this table on department column. Then I will also the index got created. I have an index on this column and I have index on this column. I still do not have an index on this column. So if I check the explain plan, it is still doing a full table scan. So if I am joining on 2 columns and if I create only on 1 column, it is still useless because over here, it's when I say over here, it will again go and check. So it has to have on both sides. So let me create another index on the other table. The other table is this one. Okay, and I cannot use the same department ID, right? The same index. So I will say depth underscore department ID. Create a brand new index on the department table. Okay, that's index got created. Oh, let me this out. Okay, now I'm no longer doing a full table scan. See, my cost is very low now. Okay, previously my cost was 5 and 3. Now my cost is 3 and 1. Is this clear to everyone?
Yes.
Abdul,
Yes.
it's clear, like logically it's clear to me. Just one question. This MPID, I understand that like to show us you gave the index, created an index for MPID, but if we make two tables, we don't have to give third index, right? Like a two depth ID, if we create the index for two different tables depth ID, it's okay for us, right? Like it's enough for us.
No.
So what about this MPID? That confused me.
Okay, so if you're joining on, so otherwise it will go and check. If I say where MPID equals to 1, it will check for the entire table where MPID is 1.
No, but like I don't want to like use a where. So I just have a two table and I want to make that like a.
Okay. If you don't have a where, then don't create on this one.
Okay, so if we use the where, then we have to create the index to make it like a less cost, correct?
Yes. So that's why I took a complicated query where I have joins and where.
Oh, I see. Thank you very much. Yes.
Sometimes you will see joins and where at the same time. At that time, if you just create it on depth ID, it will, and you're still using a where, it will still do a full table scan. So let me drop this index. Let me drop index. Let's say drop index name. So that index got dropped. So I don't have index on this one anymore. So if I do a full table scan, see, it is still doing a full table scan. Okay. It is still doing a full table scan. Previously, MPID index was only saying 1. Now it went up to 3. Is that clear to everyone?
Yes.
Okay. Last thing I'll show and then I'll end this class. So suppose I create a table hr.emp_6_9_2020. And I will create a simple table here, MPID number, emp name, barcat 215, and I create a primary key in this column. Let me not create a primary key in this column. If I create this table and refresh this, emp_6_9_2020. So this table does not have any indexes. Now I am going to add a primary key. Will I drop and recreate the table to add primary key?
No.
What will I do then?
Alter. Table name.
Okay, the same people are always answering. I want everyone to participate. Okay, alter table name,
add primary key and the column name.
Very good. Okay, let me quickly do a commit.
No comment. It's still
okay.
here.
So I did not create an index on this table, right? I did not create an index. I just created a primary key. So if I refresh now, I see an index created on this table. On which column? On MPID. Column is created on MPID. Is that clear? And it's ascending order. So the moment you create a primary key in a column, it creates a index on it. You don't have to actually go and create an index. And these are all the indexes I created today are all bitmap index, because I'll just cover this. And so when I write a query like this, it will create a bitmap index. When I write a query like this, it will create a B-tree index. If you want bitmap index, you have to specify bitmap, something like this. Okay, just like, let's give you this example.
Abdul, can I ask if you name the primary key, is it going to be the index's name? Because I see that the code is the same.
So index name is C00898896.
Yes, and if you click on the constraints, it's the same name, isn't it?
I've never noticed that. Let me check. my computer so slow? SYS underscore C008896. Yeah, you're right. The constraint name and the index name are the same.
So if we name the constraint, it's going to be the index's name.
If you name the constraint name, yes, it's going to be the index name. Yeah, that's right.
Okay.
What was I saying? Okay, so if you say, if you do not, so it will sort this data in ascending order, even though you did not say ASC. Just like that, if you're creating an index and you don't say anything, it will create a B-tree index. If you want descending, you have to specifically ask for descending. Okay, if you want a bitmap, you have to specifically use the word bitmap. Okay. Clear?
One more question.
Yeah.
You said the primary key is also the, when we make the create a primary key, it's also index. Is it only for the primary key, or maybe if we can use a unique constraint? I know it's gonna be the nulls, but
no. When you create a primary key, no duplicates allowed, no constraints allowed, right?
Yes.
Sorry, no duplicates allowed, no nulls allowed.
Mhm.
The same way, so if you're creating an index based from your primary key, it will again be B tree only. Okay, it's going to be B tree only. It will not create a bitmap when you create a when you create a primary key constraint. Yeah.
No,
unique.
I mean unique.
Yeah. So primary key means unique values, right? Unique values means it's going to be.
Yeah, I understand. My question is that if, let's say, if we're gonna create to the table unique constraint instead of the primary key, is it also be as an index, or the primary key is only the unique constraint for the primary key? I mean, for the index.
No, when you create a unique key, it will not create a
index.
It will not create an index. Hold on.
Okay, so this is the only primary key create the index, correct?
Yes. So let me alter table name, add unique. Okay. So if I go here and refresh, you will not see any indexes. You will still see that, continue to see the same. Oh, actually, yeah, I didn't know that. If you create a unique index, it will create a primary key. Okay. I didn't know that. So yeah, if you create a unique constraint also, it will also create if you create a unique constraint, it will create an index as well.
Because of just the non-nulls, but I mean nulls, but there's no duplicate. So index means that no duplicate. So it means that it's gonna accept as a index.
That's an index, correct? Okay. So far, I did not know this. So I always thought when you create a primary key, it creates a index, but I guess you create a unique also, it will create an index.
Abdul, can you please share the fifth question now?
The fifth question? Yeah, I have it here, right?
I mean, the queries, like if you can share with
the
us.
queries? Okay. Yes, it's a create and insert, right? Don't be that lazy. Let me give it to you.
Ramil is always lazy.
So what did I give? Yeah. Okay, this is create table for the emp underscore index, and then let me give you this one. And give you yes. Okay, wait, I need to fix this. So create index idx underscore emp id, and then Before you do that, join these two tables, create those two indexes, and then write your query to join. Okay, and check the explain plan. And after you check the explain plan, create these indexes, and then check the explain plan again. Who did this by their own?
I did, but I confused a little bit about this, the where statement, but I tried to do it myself.
Okay, is it clear now?
Yes.
Good. Let me give you this as well. Execute that and then create your indexes and then check the explain plan again. We slowed down a little bit in the last two classes, but that's okay. So these interview questions, different joins in SQL, difference between where and having duplicates, how do you delete duplicates, different constraints. Okay, this is called as performance tuning. How to create indexes. How do you increase the performance of a query? Write a query, get the explain plan, check if it's string full table scan, create indexes on joins and wheres, create bitmap on the column which has duplicates, create B-tree on the column which does not have duplicates. So we did not do triggers. We know difference between row num and row ID. We did not do rank and dense rank analytical functions. What is an index? I did DDL and DML. I did not do views. Difference between view and materialized view. Delete and truncate column. Yes. Difference between union and union all. I did not do. NVL decode and sequence. I did not do. Change the structure. Yes, I did. That's one dual SQL loader. I did not do partition. Okay. So out of this 26, I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16, 17. Out of 26, I did 17. I still have to do 9. Okay. I don't know if you have assignment for tomorrow because assignment 6. I already did assignment 6.
So I guess we can practice this all.
Try to do the first question in assignment 7. That's all. Okay?
Okay.
Have a good night.
Have a good night, guys.
Okay, anybody questions before I end? Okay. I'll upload this recording in like 30 minutes, okay? Okay, bye.
Okay, bye. Thank you.
Turan, gözde yaşlı tam sonra çıkarsan.
Şimdi sen gözleyesen, ben gözleyeceğim. Bir de alıyor çıktı. O bir sen nerede baklar hemen çalış.
Ulan səfehlə telefonla satan gibi xəbərləri yoxdur işlətən.
Kamran hanı?
Kamran bağladığı işi var. Məyamdadır.
Ha? Kamran səbri çatmır, axıracan baxmağa.
Tez bağladığı işi var, telefonla danışır. Haydi hocam, görüşürüz.
Education.
Haydi hocam, görüşürüz inşallah.
Sağ ol, görüşürüz. Sağ ol.
Sağ ol.